And in problem number 3, we're computing permutation of 6 objects 3 at a time. So we're going to have in the numerator 6 factorial, right? That's n. n here is 6, the first component. And in the bottom, we're going to have n minus r, 6 minus 3 factorial, right? n minus r, 6 minus 3 factorial. And if we do this one by hand, we're going to get 6 factorial over 6 minus 3 is 3 factorial. And we can simplify this. 6 factorial we could write as 6 times 5 times 4 times, and now what happens here is we have 3, 2, 1, but that's 3 factorial, over 3 factorial. The 3 factorials are going to divide out, cancel, and we are going to be left with 6 times 5 times 4. 6 times 5 is 30, times 4 is 120. And in problem number 6, we're asked to compute how many ways can we choose 2 objects out of 12. And that is, we want a combination of 12 objects, choose 2. So let's start by writing the formula here. We'll have the formula for combination of n choose r is n factorial, same as what we had for our permutations. N factorial is the total number of objects that we have. That goes on top factorial. And in the bottom, we're going to have r factorial, the number of objects that we're going to use. We're going to use r objects, and then times the number that we're not going to use, which is n minus r factorial. And actually you can see the formula right here for permutations. And in permutations, order matters. Combinations, order doesn't. So what we're doing is just dividing out the number of repetitions. And in this problem, we're asked to compute the number of ways to select 2 objects out of 12. So let's compute here. So the top number is going to be the total number of objects that we have. We have 12, we'll factorial that, divided by the number that we're going to use, which in this case is 2 factorial, times the number that we're not going to use. And if we have 12 and we're using 2, we're not using 12 minus 2 factorial. Let's simplify this. 12 factorial on the top, 2 factorial on the bottom, times 12 minus 2 was the 10 factorial here. And the 12 factorial on the top, we can write like this, 12 times 11 times 10, but from the 10 all the way down to 1, that's 10 factorial. We'll write the factorial there, 2 factorial here, times 10 factorial. The 10 factorials are going to cancel, and then we are left with 12 times 11 over 2. 2 into 12 will go 6 times. 6 times 11 is 66. So the number of ways of choosing 2 objects out of 12 is 66. In problem number 12, we are asked to compute number of permutations in objects taken 2 at a time. That means out of a total of n objects, we want to arrange 2 of them at a time. So we'll start with our formula for permutations of n objects taken r at a time, and let's start replacing our numbers. So we will have the permutation of n objects 2 at a time. This is going to equal, our top number is the total number of objects that we have, n factorial, and the bottom number is going to be n minus 2 factorial. Now what we would like to do is to simplify this, and to get the idea of what to do here, the top number is n factorial. This one you notice is 2 less. So we're going to break this n into numbers such that we'll have n, 1 less, and then 2 less, and then we'll have a match and we can cancel. Now that's pretty much the same idea that we did over here. Look what we did back over in this problem. We had 12 factorial and in the top, and in the bottom we had a 10 factorial. I want to take this 12 and write it so that I get a 10 out of here. So I'll start with the 12, decrease it by 1, decrease it by another 1. Now that's like this. I'll start with n, let's do it here. We're going to start with n, decrease it by 1, decrease it by yet another 1, and then we can factorial that because this now matches the bottom, and we're going to be able to cancel that. So here's the denominator, n minus 2 factorial, and now you can see that these are going to cancel, and we are left with n times n minus 1. And we'll leave it just at that. In our problem number 15, we're asked to compute this expression right here. How many ways can we select n minus 2 objects out of a total of n objects? So let's start by writing our formula for combinations. Our formula for combinations, n choose r, is n factorial on the top, and in the bottom, the number that we're going to use, r factorial, times the number that we're not going to use, which is n minus r factorial. So there's our formula, and now we'll start filling things in. So our particular problem asks us for this. N total objects, out of those choose n minus 2. So let's see what we have here. Now the top is n factorial. That's the total number that we have. So that's going to be an n factorial. And then the r, the number that we're going to use, is n minus 2. So we're going to write n minus 2 factorial. And then times the n minus r. So this is going to be this, right? N minus r is going to be this n minus n minus 2. And in our problem, that looks like this. It's going to be n, right? It's going to be that n, and then minus r, or in our case, n minus 2. So since there's more than one term, I'm going to use parentheses to capture all of it. N minus 2, close, and then we'll factorial that. So let's start to simplify a little bit. In the top, we're going to have an n factorial, and then down here, we have an n minus 2 factorial. And now for this term right here, we're going to get, let's just distribute that negative sign, that minus sign, n minus n plus 2 factorial. Continuing on, we're going to get n factorial over n minus 2 factorial times, so what happens here? N minus n is 0, that's gone, and we're just going to get a 2 factorial left. Now on the top, let's break this top down until we get to n minus 2, and then we'll factorial that and be able to cancel. So we're going to get n, 1 less, n minus 1, 2 less, n minus 2, but that matches our bottom, and it goes all the way down, so we're going to factorial that, over n minus 2 factorial times 2 factorial. These n minus 2 factorials cancel, and we are going to be left with n times n minus 1 all over 2 factorial, which is 2. Now problem number 18 asks us to compute 10 factorial divided by 4 factorial. This is pretty much what we've been doing already with the simplification of the top. So let's just continue this on here. 10 factorial, we're going to break this down until we get down to the 4 factorial and then cancel. So we're going to get 10, 9, 8, 7, 6, 5, 4, but then that matches the bottom, so 4, 3, 2, 1, we're going to factorial that over the 4 factorial, and now you can see that the 4 factorials cancel, so we are left with the 10 times 9 times 8 times 7 times 6 times 5, and if I did that correctly on my calculator, I'm getting 151,200.